Hi viewers, this video is in response to a question asked by our viewer named Jia Gupta. The question was, what is the difference between geosynchronous and geostationary satellites and their applications? Before we go further, let us first understand what is geosynchronous and geostationary orbits. The word geosynchronous means something which is synchronized with Earth. So a satellite in geosynchronous orbit would make one complete rotation of Earth in exactly the same time as Earth completes one rotation around itself. That is 23 hours, 56 minutes and 4 seconds. A special case of geosynchronous orbit is geostationary orbit. This is a circular orbit at 35,786 km above Earth's equator. Like a geosynchronous orbit, a satellite in geostationary orbit would also complete one rotation around Earth in one day, that is 23 hours 56 minutes and 4 seconds. But the main difference is it also moves exactly at the same speed and direction as Earth. Just as two cars moving in same speed and direction appear to be stationary to each other, the satellite in geostationary orbit will also appear stationary to Earth, thus the name geostationary. To understand this difference better, let us take the following example. For a person standing on ground and watching the sky, a geosynchronous satellite would be at same position in sky, say point A, at exactly the same time of the day every day, say 12 pm. Thus, at 12 pm of each day, the geosynchronous satellite would be at point A. For the same person watching a geostationary satellite, it would appear at same position, say point B, throughout the day, that is stationary to him. Thus, any time of the day he looks at the sky, this geostationary satellite would always appear at point B. From the above difference, we can see that a satellite in geostationary orbit would be very easy to track from ground. That is, the antennas of the ground station can point to the same position in sky, that is point B in the previous example we saw, and need not change its position except for few minor adjustments. This makes the system much simpler. This is the reason why geostationary orbits are preferred orbits. The only reason a non-geostationary geosynchronous orbit is used is as follows. A geostationary orbit cannot provide good coverage in high altitude areas, that is polar regions beyond Arctic and Antarctic circles. This is because as latitude of a location moves up north from equator, the ground station antennas will need to be positioned more and more towards a point towards horizon. At equator, a geostationary satellite is vertically above it, but at polar regions, the satellite appears to be at horizon. Thus, for a ground station in polar region, the signal would have to pass through large portion of land and could be blocked by land topologies, mountains and even buildings. To avoid this, the Soviet Russia devised a practical solution. They devised a special elliptical geosynchronous orbit which provides better coverage in specific polar regions. Tundra orbit is an example that has been used since the time of Soviet Russia. It is a highly elliptical geosynchronous orbit with high inclination of 63.4 degrees, similar to what is shown here. By using this orbit, the satellite would remain above Russia for most of the day for satellites used by them. But eventually, the satellite would move away and will be away for a brief period of time. To provide continuous coverage, a constellation of 2 to 3 satellites would orbit in same tundra orbit, and at least one satellite will be covering the area at an instant of time. As far as application goes, both geosynchronous and geostationary satellites are mainly used for communication, broadcasting, positioning such as GPS, and for monitoring weather conditions. Alright viewers, what do you all think about this answer? Do let me know in the comments. And if you have any other questions regarding aerospace, do ask them in the comments below. And as always, do subscribe to our channel for more aerospace news and facts.